Math with Oscar class. That's my dad.
Alright, next up in our list of things to cover in Chapter 2's content for Unit 1 of Algebra is the idea of absolute value. Now when we talk about absolute value, by definition, we are talking about the distance a number lies from 0 on the number line. So for example, 3 is 3 units from 0. So the absolute value of 3 we write as 3. It's 3 units along the number line away from 0. If I look at the number negative 2, negative 2, right there. It is 2 units away from 0. 1, 2. So the absolute value of 2, negative 2, is simply 2. Most people think of absolute value as stripping the sign off of a number. So the absolute value of, say, negative 10 is simply the value of 10. We don't overly think about it in terms of where it sits on the number line. Absolute value gets used a lot in math and science when the sign is not important to what we're working with. We want to have a tool in order to quickly and easily get a positive number into an equation that we're going to be using. Its origin, however, is that number line. How far something is away from 0. What we're mostly going to focus on, however, when it comes to solving equations with the absolute value, is how we're not sure exactly what was in here in the first place. So let's take as an example. I have the absolute value of some number, and I know that that number, when I've taken the absolute value, is 6. So here's the question. What number was in here that when I stripped it of its signs by using the absolute value function, I got a positive 6? And there are 2 possible outcomes. One of them is that I had a 6 in there. The absolute value of 6 would be 6. Absolute value of 6 is equal to 6. On the other hand, it could also be negative 6, because the absolute value of negative 6 is also 6. And I don't know which it is. So when I'm doing an equation that uses absolute value, I'm going to find myself having to consider the 2 possible cases, the positive and the negative case. Let's look at a couple of problems and see if we can get a little more clarity on what I'm talking about. Alright, here we have a classic absolute value equation. X plus 2, the absolute value of it, is going to equal 5. Now as I said before, we need to consider the 2 possible cases. That the number in here is either a positive or a negative, and I don't know which until I actually consider those cases. So I'm going to write case 1. Since I know that the outcome of the absolute value is that I got a 5, I'm going to say, well, maybe this number in here is also a positive 5. So I'm going to write x plus 2 equals 5. Now I can solve it. Subtract 2 from both sides. And I get x is equal to 3. I got that by subtract 2 from both sides. When I talk about the other possible case, case 2, now in this case, I can say, well, maybe that number in there is a negative 5. X plus 2 is equal to a negative 5. Now this is also where the writing becomes important, because when you do these problems, I want you to write, when you split your cases, is absolute value has 2 possible inputs. Now let's say 2 possible values. 2 possible values. So now in case 2, I say it's a negative 5. So I'm still going to subtract 2 from both sides, which is kind of nice. I'm doing the same thing algebraically. Now I can say x is going to equal negative 8. Now, it seems strange, but I'm going to be getting 2 answers here. So we can go back and let's verify. If I do my check, x, so 3 plus 2 absolute value, does that equal 5? Well, that's the absolute value of 5, which is going to check out. Works. Now let's consider negative 8. Negative 8 plus 2, negative 7, plus 2, does that equal 5? And that's when I take the absolute value of it. Well, that's negative 5, absolute valued. And that means 5 is equal to 5. Checks out. So I can see that either number could go in because the absolute value strips the sign off. Either of these two numbers, negative 7 and positive 3, are solutions to my original equation. The absolute value creates this two-case possibility. Let's look at some more problems. All right, let's look at another absolute value problem. Now, part of the trick to this is while the absolute value looks a lot like parentheses, and it's very tempting to distribute, you want to kind of hold off from doing that because you want to make the problem one where you work your way down and get yourself into a place where you have the absolute value of something equals a number so that you can split it into the two possible cases. So in this case, I'm going to begin by dividing both sides by 4. So divide both sides by 4. That's my opening step. That's going to give me the absolute value of 2x plus 1 is equal to 7. Now I'm going to break it into the two cases. So because of absolute value, there are two cases. So now I'm going to write case 1. And that's the case where 2x plus 1 is equal to 7. And then I'm going to write case 2. And that is the case where 2x plus 1 is equal to a negative 7. I don't know for sure which is the true case. I do know that both are possible. Now, because the equations are very similar, I can write them side by side. I'll be doing the same algebra work on each. I'm going to use my writing here in the middle to represent my explanation of my steps. Subtract 1 from both sides. Gives me 2x is equal to 6. So subtract 1 from both. And I can do that over here too. Let's subtract 1 from both sides. There's my equal sign. So 2x is equal to negative 8. Now I've got my 2, so I'll divide both sides by 2. I get x is equal to 3. I come over here, divide both sides by 2. I get x is equal to negative 4. And that was done by dividing both sides by 2. So now when I look, I have two solutions. I have x is equal to negative 4 or x is equal to 3. Both those are legitimate answers. Either number, 3 or negative 4, is going to make my initial equation true. I can always check that if I'm unsure of that, just to be on the safe side. Like say I take negative 4. 2 times negative 4 will be negative 8. Plus 1 will be negative 7. The absolute value of negative 7 is 7. Times 4 is a positive 28. Now, we're going to leave with a bonus question. Are there any cases where I could have an absolute value equation that cannot be solved? Think about what the problem would look like if when I prepared my cases, I could not break them into two cases because there was no number here that I could take the absolute value of and get this number here. Be prepared with that when you come to class, and there may be something in it for you. So think about that. The question again, how might I write an absolute value equation that has absolutely no solution because of the way the equation is written? All right, good luck. We'll see you next time.